let's jump into it. So first, the credibility slide, the mandatory one. Who am I? Been around for a while in IT, a bit more than 30 years, 40 years on how you count it. Mostly business informatics, but also worked in system administration, a bit of programming, IT security. And these days, people think I'm a CTO and pay me for it, so okay, I go with it. It's fine. Technical wise, yes, this one, heavy user of OpenBSD. Where I can't use OpenBSD, I use Debian. And then, of course, for everything that I write, Python, and I guess that's why I'm here. So, legal stuff quickly. So what I say today is my personal experience. It's based on what I've seen in these past years. What I want to talk a little bit about. This is by no means a scientific paper. This is by no means a proper, fully researched chronological order of the history of IT. That would be a bit outside of 20 minutes presentation. So what I'm talking about is focused on SMEs, small and medium-sized enterprises. I'm not going into the situations or what I see with larger ones, like let's say Google, Facebook, you know them. Those always live a bit in a different reality and they can shape the different reality. What I'm interested in and what I'm working with is companies in the size of a couple of hundred, maybe 1,000 people, so classic SMEs. Those also make up about 90% in most of the European countries of the economy. So those small companies are actually the core of the economy, and those are very often the companies where you are working, unless you have a nice, big, good-paying job at Google, but otherwise you are in an SME. So that's what I'm focusing on, and as we know, the SME job offers that we all are familiar with. I would like to start the presentation with a quick overview, about 10 slides. What has happened historically in IT for developers? What have we been dealing with? And how has IT looked for SMEs, especially during that time frame? And I think it's important to give this look back because many people that I meet, for example, during job interviews, have worked in IT or as a developer 3, 4, 5 years, maybe 7 years, and they can sometimes be considered a senior at that point. But you really have to look further back, 20, 30 years, to see tendencies on the market and how IT works. So let's start with the good old days, 70s, mainframe, all of that, dinosaurs roam the earth. Back then, when you were a programmer, you basically made everything yourself, even if you had a computer. So some SMEs had computers. If you go on Wikipedia, PAX is here the word that you want to look for. But you had to write everything yourself, sometimes up from the hardware. So classical programming languages, assembly, C, BASIC, and so on. One thing that you will see on my slides is the point for politics and the legal area. Please keep an eye on that one. Back then, basically the legal area, politicians, completely unaware of IT. They knew there was something there, but they had no clue whatsoever. When we go into the 80s and 90s, bad hairstyles, a lot of neon, then we are talking about the first IT, the first computers in companies, typical PCs, but everything standalone. At some point, novel networks, so you had local area networks. But as a programmer, basically, you were partly a developer, partly an admin, and you made sure that what you provide to the company works for the business purpose, but you are kind of seen as an elaborate typewriter. IT was basically an evolved typewriter. And that's what you're focusing on in the daily work. In terms of programming and what you were writing, it's mostly data export, import, be it on diskettes or printouts, later on CDs. So this is kind of the work that we're looking there. Tooling, we had now operating systems and a couple of basic tools, maybe sometimes third-party libraries, but otherwise also a lot of reinventing the wheels. If you ever needed a queuing system, if you needed database access, you wrote all of that yourself. So as a developer, you still needed to have a very good understanding of what you're dealing with here and going down to the hardware, if needed. When it comes to political and legal side, they were aware that now these electronic typewriters with TVs in front kind of were popping up in the offices, but it was handled just like all the other office supplies. Contracts, responsibilities, but nothing more. Where it got interesting was in the 2000s, when the internet kicked in. So at that point, suddenly information exchange became widely available. And I don't mean just Napster, LimeWire, and all the tools that none of you ever should use. I mean general information exchange, because suddenly in the broad public we could have news groups, we could exchange email directly. Of course this was available on universities before, but around that time it became broadly available. So this of course also created now first this really community feel between developers where you could exchange code, ideas, but also libraries, runtimes, whatever you wanted to exchange. So suddenly you didn't have to reinvent the wheel, you just got it from somewhere else and reused that, legally or bad people illegally, of course. This is also where this whole idea of software should be free in terms of cost, so free as in beer, and where you want to reuse things from other people. If we look at the business side, so now the developers were an essential part of the business, so it was recognized that we need software, that we need people there, and that they are part of what we provide to the general product, to the general business. There were alignment on protocols, so you didn't have to reinvent everything, and there were commercial tools that you also could use. Language-wise, the classics, Microsoft Net came up, Java came up, Python came up. HTML was still mostly manually written, I would say, and then there were a couple of other mistakes that we don't talk about anymore. Politically, they also started to wake up, because when we started to distribute and communicate data, information, and of course it came from the whole Napster, MP3, music exchange, movie exchange, politicians and the legal part started to wake up that there's a problem. They are affecting a business, that business, if I may say so, is paying us money, of course without any thoughts, so we have to protect them. So the whole copyright issue came up around 2000. But otherwise, again, the legal side, the political side was pretty much asleep. They just wanted to make sure that nothing illegal happens. When we go closer to 2010, so now this IT development is part of the business process. Companies are fully aware that what we write in software, what we do in software is at the core of our business. It's no longer a tool, it's no longer something that is attached to the business, it's something inside the business. And this also led us to handling ICT risks, like any other business risks. On the other side, since this takes a lot of work, companies also started to outsource more, to use ICT services from the outside, and that led for the developers to move even more away from the technology, even more away from the hardware, from the low-level stuff, and more towards SDK, framework, integration with other services. The typical languages that you see here. On the legal side, what we have now is that it's been recognized that IT is a field in its own, and that we need to handle it by contracts and by starting to have specific laws and regulations for the purpose of business IT services. This also led them to the counter side that politics recognized now customers are using ICT services, so we need to protect the customers as well. So this was the time when, for example, GDPR came up. So it was this awakening of politics. There is now a new service, there is a new kid in town, if you want, and we need to do something from the legal side. And this, of course, started at that point also to affect programming development directly. I guess and I hope everybody is aware of the GDPR and what it means for your daily work if you're a developer. When we come closer to 2020, things get interesting. Because now everybody is really awake and starts to understand that all of this IT is supporting us as a society, but also threatening society. So it's no longer on the business level, it's up on the society level. Businesses, but also the political sector realized code is the law. And if you're a politician and you're used to making laws, steering a country or larger areas by law, and you suddenly realize there is another player in town that has the same power, then you awake. Then you start to see the need to do anything, to do something. So what we see here is on the business side, that ICT, programming, the software, everything is at the core of the business, and now we have the switch, that everything else in the business, the physical goods, are now an attachment to the software side. So there's this switch happening between 2010 and 2020, going from IT being attached to now everything else being attached to IT. When it comes to the development side, so the classical developer in SME countries is now completely on orchestration. You don't write anything low level, you don't write any new libraries, you don't write anything that can be reused. You orchestrate other things. This can be a web framework, this can be a complete outsourced service, basically anything as a service. SaaS, PaaS, security as a service, anything you want to sell or name, you give it a fancy buzzword and you call it as a service. So that's the situation that we have here. As a side effect, politics also started now to push back and say, okay, we have all those companies that we have no clue what they actually do, Facebook, Google, you name it, but let's make sure we push them to enforce the law. So you have that, for example, when you upload copyrighted images. Previously, it should have been that the police or somebody else investigates that and goes after the people who break the law. But now here comes the push that politics go directly for the companies and say, we have no clue what you're doing, you enforce the law. So this shift is happening here. And this means then, of course, that in those companies, the developers that implement the requirements into code get the requirement to implement and enforce the law. So this is a shift that happened between 2010 and 2020. And that brings us then to today. Where we are today, we basically can only describe as politics and legal is striking back. They are in panic, and now they are striking back. And they're striking back hard. Because for them, it's in the end a fight for survival. If Google or Facebook is a bigger political power than the local politicians, they have to do something about it. Otherwise, they're gone in 20, 30, 40 years. They understand that. So what's happening now is that politics makes law, and they push the laws, again in this sense, they put requirements on the companies, which means that those requirements will very quickly come to you as external requirements that you have to implement in code, that you cannot bypass. If we go into some examples here, so it could be on the more formalized or more regulated space, be it banking, be it the area, for example, that my employer works in. We're working with digital signatures. We are, by regulation, required to use certified components. We are not free in the choice of what we can use for certain areas. And of course, everybody in the industry by now uses standardized pipelines. Nobody does anything out of the ordinary, the more they're regulated, because they have to handle the risk. One other example where this push is very visible, if you follow the news lately, is the end-to-end encryption discussion around Facebook and other services. Of course, they would like to implement complete end-to-end encryption. But as you can understand, law enforcement and politics has an issue with that. So they even have the power to try to force Facebook and large and similar entities to not make end-to-end encryption. And Facebook or Google can fight back against that. Smaller entities cannot. So they have to take the requirements and give them down to you as the developer to implement. And you cannot bypass them. So this also leads us then on the language side, if we go back a little bit to technology. Previously, in IT and design, we chose what was best fit, but now we really have to focus on anything that keeps us secure, anything that reduces stability issue, and especially coming from top management, whatever you do in IT, anything that does not open us up for any legal actions against us. So there are a couple of very interesting requirements now coming down to us on IT design and on software design. So, some of the drivers. I don't want to go into the details here, but if you're a developer and you are not aware of those acts or laws such as NIS2 or PSD2, if you have anything to do with payments, you must read them. Not just to have a good night's sleep, but also to understand what is the political intention behind those laws, which then go through one or two more filters until they arrive as product feature requirements on your table when you have to implement. And this is also kind of this thinking. I said before, the code is the law. As a developer, you're used, and we're used, what we write in code, what we design is what's getting executed, so we shape reality by writing the code. Fair enough. But here's the thing. Politicians have done for hundreds, if not for thousands of years, to write actual laws. And they can enforce the law if they want and if they have to, by the courts, by the police, and in the last stage by military. This is a slightly different situation than a developer who writes code and that code may be bypassed. So here I'm coming back that those requirements will apply to you and cannot be bypassed. Some examples, if you read the news also, some countries have already arrested CEOs that do not follow the local requirements. And I'm not talking here just about countries like China, this has also happened in other countries. So politics are already putting this pressure on the top level of companies to comply with the requirements. And you can expect the top level of the company to push this down to you as the developer or designer. And maybe also have a little bit a lighter example, if you want, from my personal life. In one of the companies I worked with, one of our salespeople who had a company car didn't pay a traffic ticket. So the police, after a while, looked up who owns the car. It was the company. So on the weekend, they went to the general manager of the company, to his house, knocked on the door and said, here, there is an open traffic ticket for something like 20 euros. You want to pay this now, or should we take you to the police? Obviously, he's paid. Obviously, you can imagine what kind of talk on Monday happened between the CEO, the general manager, and the salesperson. But also, he immediately implemented processes internally that this will never happen again. And this we will see more with this coming forward. A small side note also, this is not just coming from politics. This was an interesting one. The Hollywood writers are going on strike right now. They want to get a legal clause that the studios can't use AI to make scripts because that will put the Hollywood writers out of business. I haven't seen something similar. I haven't seen a single developer going on strike asking the company, if you don't forbid AI that could replace my job, I'm going on strike. Think a little bit about that. So what's the message that I'm trying to relay here? You basically get pushed from two sides. One is there will be way more external requirements from government and legal side for the reasons that I just described. And again, the big companies can fight back. Google, for example, or Facebook can say, no, I will not implement this, I pick a fight with the European Union. Anybody else cannot pick that fight. So they simply have to accept this and implement this. And typical requirements here that are coming is GDPR, of course, that we know already. There's the tendency that all the countries want to keep the personal data, financial data, and other data within their geographic and thereby immediate grip area. There's a strong, very strong push that companies and Indian developers are accountable, legally accountable for the software they provide. So if that goes wrong, if it can be misused, if it can be misused to spread false information on the internet, there is a strong incentive right now to make the companies and the developers personally accountable for that. And we also see the push that, for example, in the European Union, if you want to be in that market, you have to have a legally accountable person in that market. So if you want to sell in Europe, you have to have a company and a legally accountable person in Europe. So in the worst case, they can arrest that person if things go wrong. Same thing in China, same thing in a couple of other countries. And that person, of course, depending on how the company is set up, will then make sure that the company behaves accordingly. Or you put a scapegoat if you want there, but that won't work well with the local law enforcement. And then I want to come back to the technical side. So we also have this bottom-up thing that I mentioned before. We started with implementing against the technical layer, and then we said over time it became more frameworks, SDKs, now anything as a service where we just interact with web services. So this is where we are today. Nobody's writing low-level stuff anymore. And I'm talking here about the typical SME, about the typical business developer. I'm not talking about people working for specific hardware companies. So I'm talking about the general case. Everybody's just picking from what's available. There is nobody is making new chips apart from Facebook and Google or Apple. Everybody of you is programming either for Linux or Windows, some version of Linux. Nobody's really making a new crypto algorithm or anything for secure transport. All of that is already established. So what in the past, in the last 30 years, was a broad spectrum where I could choose from, make my own implementation, but also waste resources, of course, has now become a smaller set that I choose from. And given with the legal push, I will, even from that small set, only select what reduces the risk, legal risk and so on, regulatory risk for me as a designer and as a developer. So, summarizing this on 2 slides a bit more in a graphic way, up till now, the job for the developer and the designer was find a path, make this happen, make this work. But now it's do not leave the path. Use something that's well established, well traveled, do not stray from that path or we have a legal, regulatory, financial, whatever problem. So make sure you use components and designs that keep us as a company safe and secure. In a different picture, up till now, there was a lot of tech skill requirement in order to implement a little bit of functionality because we had to do everything. It became better over the years. But what's happening now is that the companies need a lot of functionality, but with not so many tech skills. So the focus is now on interacting with the business. This will go down. So has this happened before? What I'm talking here is it's just some wild ideas. I have 2 very good examples, I think. Going way back in time. When the first cars came around, 1900, something like that. Basically every engineer, everybody who had a technical education could put a car together. You just needed to make some kind of engine. By the way, the first electric cars were around 1900, so take that even. But everybody who had the engineering skills could make a car and drive around with it. And there were very interesting vehicles driving around. But as you can imagine, this didn't go well because more vehicles came around, there were car crashes, horrible accidents, and so on. So things got regulated. And if you look at how cars work these days, you cannot make your own car. Not completely correct. You can build your own car. You're allowed to drive in your garden with it. You're not allowed to touch the public road with it. So that's where we are after 100 years of regulation of cars. And even your own car, you're barely allowed to touch it. You're not allowed to modify it or anything. And another area that I personally have experience with, HVAC, that's heating, ventilation, air conditioning. So in that area, originally engineers, and to this day, still learn all the physics, stream dynamics, dynamic system behavior, and so on. But what they actually build in the buildings is ready-made components where they have to understand how they work, but they just put together ready-made components because if they don't do it, you get into compliance problem with fire protection and so on and so on. So this is also an area that very quickly since the 50s last century was regulated and where today the educated engineers are only putting together components and making sure that the whole thing is compliant and safe based on their technical knowledge. And this is the direction that software development is going, in my opinion. And not in the next 50 or 100 years. I think this is going to happen in the next 10 to 15 years, so during your work life. So, that leads us, of course, to the old cliffhanger from the first slide. So what should you do? What do you need? So, in short, you need to understand what your product, what your software that you're working with is doing in the company as part of the business process, as part of the requirements that are on it. Legal and governance. I know this is tough to swallow, but those are your best friends. You need to start to talk with them, you need to start to understand the language, and you need to be able to read laws and regulations and understand the intention. Do not try to reinterpret them. Even lawyers have problems with that. But as a developer, as a designer, as a team lead, as a scrum master, you must understand the requirement and the intention of the requirement so that you don't break them. And you have to live security and risk management, not just on the technical level, but also coming back to the legal level. Data protection, any form of legal protection if you want. The last thing is a bit controversial, but I am ready to die on that hill. The architect, designer, developer, all of those roles will become shades of gray of the same role. And I do believe we will have to bring back the term of the software engineer. People who design software according to business needs and who can make good designs with all the requirements around it and how to fulfill them. So I strongly believe we have to bring this term back, educate for it, train people for it. Which also means people who have no formal education, who only learned programming over 2 or 3 years, will in 10 years from now have a very, very tough life. Toolbox, quickly to go through that. So what do you need on the technical side? You definitely need to have your patterns and workflows ready. So how do I make a good login? How do I make a good data transfer? How do I do authentication? You need to have that ready. Nobody's going to re-implement that, and nobody's going to sign off a non-standard workflow anymore. Security-wise, you have to understand your components. So it's no longer just nice to see what can a component do, but more important is What's the security history of the component? Can I trust this component? And I'm very much looking at Django in this case. I'm also ready to die on that hill. So I can only choose components that have a good security and where I know the architects and developers behind it are mature and can maintain that in a good way. Otherwise, I'm digging my own grave here and bringing in a risk. And when we're talking about suppliers, so I need to understand, what is my supplier? Do they run a risk when they work with me? Can I rely on them? Can I rely on them to be around for a couple more years? Do they have a skin in the game if their component goes bad? Or is this just some project of a student and they don't care if the project goes bad? So I have to take all of that into consideration, and I have to understand all of that even as a developer and designer. So we're running short on time, but maybe we have one or two questions. Go for it.
So you say that it's required to communicate with legals, but they are very, very slow. What to do with that? So how we can fix that?
So the question was how to deal with legal because they're very slow in terms of working. As with any other requirement, acceptance criteria, requirement management, they have to put it in written, and legal is very good in dealing with written things. So they have to put it into acceptance criteria, and then it moves into the development process, as usual. And they have to learn how to write legal acceptance criteria, but that's less of a problem. They are used to dealing with text. Yeah, sorry, somebody back there was first.
Yeah.
Just shout.
Why do you think people that have picked up software engineering on the side or outside of the forum, education context will have a hard time in the next 5 to 10 years?
So the question is why I think somebody without a formal education will have a hard time. That what comes back to this slide. You need to have a good understanding of the theory behind development and design, how to structure things, it starts with how to structure good classes in object-oriented programming, but it then goes into structuring your work, making a good architecture and design. All of that requires a bit of formal education and theory. Like for example, if you want to build a compiler for whatever reason, you need to have the theory of how graph trees, call trees, and all of that works, how algorithms for register assignment work, and so on. If you never had that knowledge, if you only go to Stack Exchange, you will never make any good quality work, so you will be a liability for the company, and they will place you in the pool of, I have to say so, unskilled IT workers instead of in the pool of engineers. That is the argument here.
Yeah, given all this great picture of where everything is going, how do we still have fun in our jobs?
Drugs? No, sorry. So the point here is that has to be an intrinsic interest of the company, because like any other employee, and engineers become like any other employee, you have to motivate your people. How does the salespeople have fun? How do the marketing people have fun? So it's the same thing. The one plus that you will get is you get more stable components. So it's less of the unexpected errors. It's more deterministic of what you're dealing with. But you also have to live with the fact that you can't just select anything, make anything. You will be more, if you want, the gear in the wheel, like any other employee in the company as well. Or you go to one of the big companies that still make core IT products, but they select the best ones. And if you ever done an interview on the farm companies, you know what I'm talking about. But basically, playtime and kindergarten is over, if I may say so. Now it's working.